Welcome to lesson number 1 on rational expressions and equations. We're going to be looking at what rational expressions are today and just keys to this unit to help you succeed. Now, in previous courses and in previous units, we've looked at what rational numbers are and what rational expressions could mean. But today we're looking at rational expressions and one specifically that contain two or more polynomials. So for example, x plus 7 divided by x plus 8 is known as a rational expression. Similarly, if we have a rational number, we can have any fractions like 4 over 7, 2/5 would be examples of rational numbers. Now, if I could have a single variable rational expression, and that's if we have an algebraic fraction in which one of the variables is a numerator and denominator are both polynomials. So here's two examples of what that means, or what those look like. Some things that will be helpful in this unit is recalling the different methods of factoring polynomial expressions as outlined here. So let's begin by looking at this investigation. If we consider the rational expressions 2x plus 2 divided by x squared plus 3x plus 2 and 2 divided by x plus 2, we want to complete the table for each value of x. So I'll do the first two. So where x is equal to 0, I would have 2 divided by, or 2 times 0 plus 2 if I substitute my value of x into my expression, times 0 squared plus 3 times 0 plus 2. This would leave us with those zeros, 2 over 2, which is equal to 1. And if I do 2 over 0 plus 2 again, we're going to be left with 2 over 2, or 1. And then when x is equal to 1, all I need to do is substitute my value of x into my expression, 2 times 1 plus 2 divided by 1 squared plus 3 times 1 plus 2 is going to be equal to 2 plus 2 is 4. 1 plus 3 plus 2 is 6 is equal to 2/3. And if I have 2 over x is 1, 1 plus 2, we have again 2/3. So as we complete this chart here, what we're going to find is, if we answer question B, what can we say about the values of our rational expressions 2x plus 2 divided by x squared plus 3x plus 2 and 2 divided by x plus 2? Well, if we look at all the values of x and substitute them into our two expressions, we'll find that each of these values are equal. So they're each equal. Now the expressions 2x plus 2 over x squared plus 3x plus 2 and 2 over x plus 2 are known as equivalent forms of a rational expression. To explain why they are equivalent, read the following procedure and complete after step 2. So why are these equivalent? Well, if we write the numerator, so 2x plus 2, and the denominator, x squared plus 3x plus 2 in factored form, we can reduce the rational expression by then dividing out a common factor and then canceling out the factors. All right, so we'll show what that looks like. So first of all, 2x plus 2, we can factor out the 2, which would leave me with x plus 1 in these brackets here. And x squared plus 3x plus 2, we can also express as a factored polynomial. This would be x plus 2 times x plus 1. Now, if I have something like this, our factors can then cancel out. So this x plus 1 and this x plus 1, we can cancel out, leaving us 1 and 1, which ultimately would leave us with 2 over x plus 2. Now, when I have 2x plus 2 and x squared plus 3x plus 2, we can write that in the form of 2 over x plus 2. This is said to be in lowest terms, or in simplest form. Now, one thing that you might want to notice is these bullet points here, is that the 2 and the x2 divided by x plus 2 cannot be further reduced by canceling the terms, okay? So what they mean is this is one term and this x is another term, and this 2 is another term. I can't cancel out the 2 and the 2. All right, I can't cancel out the 2's. Those can't be reduced. So in order to reduce our fractions, we can only cancel factors. We cannot cancel out terms. So this is very important. We can't cancel out terms. We can only cancel factors. So we've looked at how to investigate equivalent forms of rational expression. Now we want to investigate non-permissible values. So again, we want to complete this table where we have values of x's, substitute them into our equation. And we want to write the value as not defined if the value cannot be calculated. So first of all, if I plug 0 in, we're going to have 2 times 0 plus 2 over 0 plus 3 times 0 plus 2. We're going to be left with 2 over 2 or 1. Same thing here. Ultimately, it will be x, which is 0 plus 2 is 2 over 2 or 1. Here when I plug negative 1 in, so we have 2 times negative 1 plus 2 over negative 1 squared plus 3 times negative 1 plus 2. We're going to be left with negative 2 plus 2 is 0, and positive 1 minus negative 3, which is negative 2, plus 2, which is again 0. And here, if I plug in 2 and negative 1 plus 2, we're left with 2 over 1, which is equal to 2. However, this is where we're going to run into something else. So if I have 2 times negative 2 plus 2 and negative 2 plus 3 times negative 2 plus 2, we're going to run into 2 times negative 2 is negative 4 plus 2 is negative 2, and negative 2 minus 6 plus 2 is 0. Here is where we have something that is undefined. So undefined. In this similar fashion, 2, negative 2 plus 2, again we're left with 2 over 0, and this is also undefined. And then down here, we're going to be left with negative 2 and negative 2 if you plug the negative 3 in. Now, let's answer these questions. For which value of x is the expression 2x plus 2 over x squared plus 3x plus 2 not defined? Now, this is also something that is undefined. We're still dividing by 0, so I should have left that. It's also known as an indeterminate. We have 0 divided by 0, but we could also express that as undefined. So we would say that at x is equal to negative 1 and negative 2. And negative 2 clearly because we were dividing negative 2 and positive 2 by 0. For which value or values of x is the expression 2 divided by x plus 2 not defined? This one was just negative 2. So why do the values in b and c result in the expressions not being defined? Division by 0 results in undefined. And the rest is information that you can read by yourself, but when we have non-permissible values, that's what we were looking at, our values of x that are going to give us an answer that is undefined. So if you're ever ending up with an answer that is undefined with the value of x, that means that value of x itself is not defined. So one thing to know is a rational expression is in simplest form if its numerator and denominator have no common factor other than 1. So in this example, we're going to express our answers in simplest form, and we're going to state the non-permissible values of the variable. So 12x squared divided by 2x. So 2 goes into 12 6 times, and x goes into x squared x times. And our non-permissible values, if we look at this one here, if this were equal to 0, then we would have a divide by 0 error. So x cannot equal 0. In this example, remember that we have factors that can cancel out. So if I have a factor that's the same as the one on the bottom, then those will cancel out, being equal to 1. In simplest form, we could express this as a minus 6 over a plus 7. However, a on the denominator cannot equal negative 7 because negative 7 plus 7 would result in 0. But it also can't equal this factor here, my variable, so it can't equal negative 1. Because if I were to plug a negative 1 earlier on into my expression, then that would result in an undefined answer. With this example here, all we need to do is begin by factoring. So we'll have y plus 4, and y squared minus y minus 20 is going to be y plus 4y minus 5. Those factors will cancel out, leaving us with 1 over y minus 5, where y can't equal negative 4 or positive 5. And this last example, x squared plus 11x plus 28, we would have x plus 4, x plus 7 over x minus 7, x plus 7. Again, our factors can cancel out, leaving us with x plus 4 over x minus 7, where x can't equal negative 7 or positive 7.